Good morning, student. Namaskaram. Uh, Today we are going to discuss one important concept from 11th physics. Yeah. So chapter name laws of physics. So in this chapter we'll have some basic fundamental concepts. First of all, momentum. Okay. Then we will go into the next topic, that is impulse. Okay, right. So momentum means it is a measure of it is a measure of the mass in motion. Okay, in motion. That is that of an object. Okay. So in our universe, all the objects have mass. Yes, you have mass. I'm having mass. Even single tiny particle has mass. Yeah. So anything, anybody has mass. Suppose that mass moving in particular direction with some velocity, moving in some direction with some velocity, then the momentum concept arrived. Okay. So momentum means how to define, sir? Yes, momentum defines the product. Product means multiplication. Okay. Product of the object's mass and its velocity. This is a simple and very clear definition for that concept, momentum. So momentum is a measure of the mass in motion. Okay, that object has mass and it should have in motion. Okay, right. That momentum is defined as the product of the object mass and its velocity. Clear? Momentum is a vector quantity. Already you are familiar with the term vector quantity. Vector quantity means if some physics quantity has a value and a direction, that quantity is called as vector quantity. So direction as well as value, that is magnitude. Suppose one physical quantity has both these quantities, that is direction as well as value, that quantity is called as vector quantity. Okay, because there is another one term which is against the vector quantity, scalar quantity. In scalar quantity has only mass only, not a direction. Okay, right. So momentum is a vector quantity. That means it has both direction as well as value. Value means magnitude. Okay, right. So the formula for momentum, this is a concept. Okay. So the formula for momentum, already I told you, that is product of mass and velocity. Yeah. So formula of for momentum, P is equal to M into V. Clear? Okay. P is equal to M into V. Here P momentum, M mass, V velocity. So speed is a scalar quantity. V is a velocity. If it is a vector quantity because velocity has both magnitude and direction. Okay, right. So then next unit for this momentum. You can check that unit with your own understanding. That is mass. Unit means kilogram, kg. Velocity unit meter per second. Yeah, correct. Per second. Some object travels per second in some centimeter or meter. So it has velocity. Okay. It has speed also. Okay. So kg for m per s. So meter per second. That means okay. So meter per second, which is a unit for velocity. Okay, right? So the unit of momentum is kilogram. Unit of momentum is kilogram meter per second. Kilogram meter per second. Now you may clear with this concept. Yeah, correct. Okay. So momentum, it is a measure of the mass in motion of an object. It is a product of mass into velocity. So P is equal to m into V. P is momentum, m is mass, V is a velocity. Then, and it is a vector quantity because it has both value and direction. Okay. Then next, units. M kilogram, V meter per second. So unit for momentum is kilogram meter per second. This is momentum. Clear? Then next concept, impulse. Second concept, impulse. So before that, suppose one vehicle, that is car, moving with some velocity. Already it has mass. Yeah. Okay. So like for this car, the mass m, velocity v, and momentum p is equal to m into v. M into v. Like for example, you can choose m, that is 200. For example, okay, 200 kg, not in kg, in ton, for example, okay. So 200 kg. Velocity, maybe 5 meter per second, okay. This is the velocity. Then momentum. What is the momentum of this vehicle? P, M, 200, 200, V, 5. You can multiply 200 with 5. That means 1000. Yeah, 1000. Unit kg meter per second. Velocity meter per second. So this is the momentum of this vehicle. 1000 kg meter per second. Okay. So it may be car, it may be ball, it may be a very small stone, it may be a person, whatever else. Something has mass and in motion, the momentum produced on that body. Momentum created on that body. Yes, now clear. Yeah. Okay. Then impulse. We will go into that next topic, impulse. Impulse is nothing but which is related to that momentum. That's why, First of all, we have to know what is momentum, and then we will go into that impulse. Impulse, it is defined as the change in momentum of an object. It is a very simple, clear definition. Impulse is nothing but change in momentum of an object. Okay. So change in momentum means what is that concept? That is change in momentum. Suppose one ball has something momentum P1. Okay. Something before collision, it has some momentum P1. After collision with some wall, okay, that ball goes here. So now that ball velocity may change. Mass does not change. Mass universally constant. It does not change any second everywhere. Okay. So mass does not change, but velocity will change according to that object. Okay. So ball incident on that ball and returns back to that same position or some other position. So the velocity of that object, that is ball, okay, the velocity of the ball may change. So in that case, there is another momentum. So in that case, there is because velocity changes. Already I told you, mass into velocity, which is gives the momentum. So mass does not change, but the velocity changes. So velocity changes means there will be a two or more momentum. Okay, right? So first momentum, second momentum, before collision, after collision. Okay. So this change in momentum of the object is called as impulse. Okay. This change in momentum of the object is called as impulse. It is also a vector quantity. It is also vector quantity because it is also has mass into velocity. Okay. Right. So so in impulse, very short uh, short duration of time, okay, in very short duration, suppose large force acts acts on an object, then the force is called impulsive force or impulse. Okay, this is also another definition for impulse. In very short duration, very large force acts on that object, then that force is called as impulse. So in previous sentence, you told that impulse is change in momentum. Now you are telling that impulse is a force. Any difference, sir? You can ask me. Yeah. Yes. Both concepts same because force is nothing but change in momentum. Already from the Newton's second law, we know that F is directly proportional to dp by dt. Yeah, that is F is equal to ma. Yeah, this is the second law. So what does that mean? Force is directly proportional to rate of change of momentum. P is momentum. Already I told you. So P, which is denoted as a momentum. So change in momentum. So force, change in momentum. Correct? So that force acts on an object in very short duration. From the Newton's second law, that force will change that object momentum. Okay, right? Momentum means mass into velocity. So mass does not change, but the velocity changes. Like, for example, you can imagine that. So here, one tree. Okay. Suppose one vehicle coming towards this tree. Okay. So already it gets mass and something velocity. So overall it gets momentum. Yeah, something. Okay. So when this bus or vehicle incident on this tree, what will happen? The tree gives some force on that object. Yeah, correct. And moreover, the tree is at which is at rest. Suppose it has a huge mass over that car, the damage very high. Okay. Okay. So the tree gives force on this bus or vehicle. Yeah, in a short duration, very large force give so which is gives by that tree, which acts on that object. Then object velocity will change. Yeah, object velocity. Yeah, already you know that because velocity is nothing but which is change in displacement. But once that car hit on that tree, that velocity should change. Yeah, surely change. So then you can say that the momentum of that car also changes, sir. Yeah. So force is nothing but changing momentum. Force which gives that momentum changes in that object. Yeah. So force which is gives by that tree changes the momentum of the object. So that's why the both concept true and as well as same, but in a different line. But both concept same. Change in momentum is impulse or that very large force acts on that object in a short interval duration of time, then the force is called impulse. Okay, right. So from the Newton's second law, we know that F is equal to dp by dt. Okay, so I can take this F is equal to dp by dt. So that means dp by dt. So dt goes here. So F dot dt is equal to dp. We can integrate over time interval because before collision some time and after collision some time. So time changes. Yeah, already time passing away. So integrating over initial time and final time, we have to integrate this. So here dt. So we have to put change in time here, initial time, final time. Here initial momentum, final momentum. So I f. I means initial, f means final. So integration of dp. So integration of dx. Already you know that x. Yeah. So integration of dp which gives p like that. So f I. And here force constant. So dt becomes as t because of integral and differentiation. Tf ti. So now you can put F here and I here. No, like for example, so final momentum minus initial momentum, which gives F dot. So, so dt. So I can put it like this. Okay, F dot dt. So F dot dt means so sorry, F dot dt. Okay, I don't need this term. Just put it F dot dt, because suppose that force constant, then only you have to take out of this integral. Suppose force does not constant, you don't take that force out of this integral. Okay, suppose force and as well as constant force in our concept. Okay, but so now you don't take a force out of this integral, because that force, it may be constant or it changed. Yeah. So Pf minus Pa is equal to integration of Tf Ti F dot T dt. So this term means force dot time. Yeah. Force dot time dt, which is impulse. Very large force acts on a short duration of time, which gives impulse. So you can put I here. So Pf minus Pi I. Yeah. So Pf minus Pi means change in momentum. Yeah. Final minus initial. So change in momentum. I. Del P equal to I. What that mean? Change in momentum is equal to impulse. I told you. Yeah. So very short duration, very large force, that concept is gives impulse. Again, change in momentum also gives impulse. So change in momentum is nothing but impulse. So hence prove. We can also prove that concept. Yeah, del P or dP is equal to I. Impulse is also a vector quantity. Clear? So this is the concept of impulse. So for example, now we can write again, that is I, which is equal to del P or dP. That means change in momentum. Momentum means Pf minus Pi. Yeah, final means initial. So momentum m dot v. So mass does not change. So m is m, but velocity change. Vf minus initial vi. Yeah, because p is equal to mv. So this is the final velocity. This is the initial velocity. In that our case, that car passing on that road like some velocity, it has some velocity that is 5-10 meter per second. Once hit by that tree, that velocity will come to zero. So final velocity different from to that initial velocity. Yeah. So final velocity, initial velocity, Vf, Vi. Okay. So this is impulse. Okay. So this is impulse. This is change in momentum. This is mass of that object, and Vf, Vi initial and final velocity. And the unit for impulse. What is the unit for impulse? You can check it out. What is the unit of impulse? Del P mv minus mv. What is the unit? Yes, that is Newton second. Okay. The unit of impulse, Newton second. Newton is the unit for what? Newton is a unit for force and also for a weight. Okay. So all we have denote kilogram for weight, but it is not correct. We have to uh, denote that weight in terms of Newton. For example, I have a 80 Newton, 90 Newton. So this is exactly correct. But all we have, all are saying that my weight is 80 kg, 70 kg. But the kg is not a unit for weight. It is a unit for mass. Okay. So mass into G, M into G, then only we will get weight. Okay. So kilogram, that is for mass, Newton for weight. Okay, that is force also. Okay, so force also denoted as Newton. So already you know that I is equal to F dot del T. Yeah, change in time with force. So force is Newton. Del T means time. Time, second. The SI unit for time, second. So that's why I'm writing I inverse unit Newton second. Clear? Okay. This is a concept of impulse. This is a concept of impulse. Okay, sir. What is a relationship between impulse and momentum, sir? Yeah, already I told you. What is the relationship between impulse and momentum? Change in momentum, which gives impulse. Yeah, that means you can tell that large impulse, large impulse will cause large change in momentum. Small impulse which cause a small change in momentum. Okay, correct? Okay. So, for example, um, you can imagine that when a cricket player catches the ball, yeah, he pulls his hands gradually in the direction of the ball's motion. Why? You can see in that sports cricket. Suppose if you catch that ball, you pull hand like this direction. Yeah. Catch and pulls our hand gradually in the direction of ball. Why? When a cricket player catches the ball, he pulls his hands gradually in the direction of ball's motion. Why? Suppose if he stops the ball, stop the ball with his hand, after catching the ball comes to rest. Yeah, but in very short time, very quickly. If he stops his hands soon after catching the ball, okay. If he stops the ball with his hands, but also he stopped that hand also. Okay, he stopped that hand also. He does not move that hand in direction. Just stop. Hand also stops. So the ball comes to rest very quickly. It means that the momentum of the ball, because that ball has momentum. Yeah, the momentum is brought to rest very quickly. So the average force acting on that body will very large. So in his hands, that object momentum delivers a larger force with a short duration of time. Okay. So the average force, this is a hand. Okay. You can imagine. Okay. This is hand. He stopped the ball. The ball is brought to rest very quickly. That ball has mass and velocity, so it has momentum also. So the average force acting on the body will be very large. Due to this very large force, very large average force, and the hands will get hurt. Yeah. To avoid getting hurt, the player brings the ball to rest slowly. That's why he brings his hand towards that ball direction, because he has to reduce that speed by increase the time. Yeah. So to avoid getting hurt, the player brings the ball to rest slowly. Okay. And you can imagine another example for suppose jumping on a concrete cemented floor. Okay. What will happen? Because it is more dangerous. Yeah. Why dangerous? Jumping on the sand will be easy, but jumping on the concrete cemented floor, it is more dangerous, because sand brings the body to rest slowly, but concrete floor slows the body very fast. Okay. So that the average force experienced by the body will be lesser. Okay. So for example, the sand brings the body to rest slowly than the concrete floor, so that the average force experienced by the body will be lesser. Yeah. Because concrete floor brings the body to rest very fast than the sand. So the average force experienced by that body will be high, will be huge, because very short duration of time. So that's why the momentum, cemented floor momentum delivers on that body and get hurt. Okay. So the man get hurt. Okay. So this is some of the example for impulse. You can imagine that. Okay. So impulse is nothing but change in momentum, very short duration time, very large force. These are all belongs to concept of impulse. Okay. Now we can move into that another concept, that is law of conservation of linear momentum. Law of the next concept, law of conservation of linear momentum. So in our nature, conservation laws plays an important role. Yeah, already you know that. Okay. Conservation laws plays an important role. There are three conservations law in our mechanics. That is conservation of total energy, conservation of total linear momentum, and the conservation of angular momentum. These are the some three conservation laws in mechanics. By combining the Newton's second and third law, we can derive the law of conservation of linear momentum. Okay. So for that, take two objects or take two particles. So these particles interact with each other. So, okay, then some after time it interact with each other. So this object exert a force on this object, and this object exert a force on this object. Yeah, they exert equal and opposite forces on each other, because by the Newton's law we know that every action has an equal and opposite reaction. If some force acts on that body, that object also gives same force on that previous body. Okay. So this object exert a equal and opposite forces on each other. The particle 1 exert a force, something force that is F21. F21 means the force acting on that second object by the first object, that is known as F21. So here F12. Second object gives a force on that first object. Okay, so this is a concept began with collision. So the object exert each equal and opposite force on each other. Equal and opposite forces. So equal and opposite force means F21, which is equal to and opposite to F12. So both forces are same, but in opposite direction. Okay, right? So in terms of momentum, okay, this is first object. It has mass m1. So that object is known as A, which travels with some velocity, that is initial velocity always denoted by u. So first object velocity, initial velocity u1. So here another one object that is which is uh, much smaller than that object first. So this is m2, and it also travels with some initial velocity that is denoted as u2. This object B. So this is before collision. So this goes like this in this direction, and this object also goes like in this direction. So this is before collision. After some time, because the velocity u1 is greater than u2, so it is travels slow in a slower manner. It travels in a faster manner. So after some time, that both object will interact or collide. So this object collide during collision. After that, that object goes here like that, the same direction. This object also goes here, but velocity changes. Both object velocity also changes. So u1 becomes as v1, u2 becomes as v2. That means velocity changes. First object velocity also changes. Second object velocity also changes. So this is after collision. This is after collision. Okay. So already we know that rate of change of momentum. Yeah. Rate of change of momentum. That is which is called as uh, m into v. But the rate of change of momentum means it depends on the time. So according to the Newton's law, every action there will be a equivalent reaction. So this object will give some force on this object. This object also exert some force onto this object. So action reaction is there by the according to the Newton third law. Yeah. So by Newton third law, we can write that is action and the reactions, but in opposite direction. Action, reaction, but opposite. Minus means opposites. Okay. So reaction. So action force, reaction force. Okay. So action force, which is nothing but change in momentum. Already I told you that is force is change in momentum with respect to time. So momentum, that is a change in momentum by time. Which is also, but this is the action. So action which is gives us from B. So B object action. Change in momentum of A by time. Because by the action reaction concept, we can write force is nothing but change in momentum, because already I told you that tree force gives on that object, that tree will change the momentum. Yeah. So action force, reaction force. That is momentum change, momentum change. The first object will give you a force on second object means the first object change the momentum of the second object. Okay. So again, I'm repeating that. Suppose two objects will collide or will collision. This object exert a force on this object. Moreover, that force will change that momentum of this object. Sure. Okay. By the same process, this object will exert a force on this object. Yeah. That force will change the momentum of this object also. Whatever mass, whatever velocity, but this is a universal concept. Okay. So whatever forces acting on that force will change the momentum. It may be less or huge. It is not a matter, but the momentum will change. So that's why I'm saying action force which is equal to reaction force, which is change in momentum of B. Okay, change in momentum of A. So in of B or in B, okay, whatever else. Okay, so change in action force will change the momentum of B. So momentum of B. Reaction force will change the momentum of A. So that's why I'm writing momentum change in momentum of A with respect to time, because F is directly proportional to dB by dt. So this is the dB, this is the time. Okay. So then next we can write in terms of M, U, V, V1, V2. Okay. Right. For this M1, U1, M2, M1, V1, V2, M2. Okay. So change in momentum of the B means, so this is A, this is B. So here collide. Okay. So this is A, this is B. So velocity changes. Yeah. So M1, sorry, for that B object. So B has mass M2. Yeah. So M2 V2, because this is the final velocity minus initial velocity M2 U2 by time. This is a change in momentum of B. Okay. Because B has mass M2. B has velocity before collision U2, after collision V2. So that's why I'm writing 2 subscript 2 for that object B. For the object A, 1. That is m1 v1. This is a final momentum because m into v momentum. m1 v1 means the first object final momentum because velocity changes minus initial momentum. Initial momentum m1 u1 by t. By the Newton third law, these two are equal and opposite, so minus. I can put minus sign here. So negative sign here denotes that opposite direction against the direction. Okay. Now you can um, solve this equation with the basic steps. How that you can cancel that t. Yeah, already you know that you can cancel that t because t on the both side for the same time interval. So you can cancel t. Then next, I can take the t. Okay, nice. You can put that minus sign into this box like so. Minus sign goes here and minus sign goes here. So minus m1 v1 and minus into minus plus m1 u1. So here m2 v2 minus m2 u2. Okay, right. So you can put that m1 u1 on that side, but this term goes into here. So that minus term after that equivalent sign, equal sign, that sign will change. So m1 u1 that term goes into here, m2 u2 minus becomes as plus. The same way m2 v2 that minus term goes here and that sign will change. So m1 v1. Okay, so you can check that. That is m2 v2 m1 v1 m1 u1 m2 u2. So we can rearrange that equation in order. That is m1 u1 m2 u2 m1 because always one first is first order. Okay, so m1 v1 m2 v2. So we can rearrange this equation like this. Yeah, already you know that. Okay, so you can see that there is a one concept behind this equation. What is the concept? You can see that this is a initial momentum of first object, that is A object. So initial momentum. So I can denote as P. Okay, this is a initial momentum of B. This is a V1. So final velocity. So this is a final momentum of A. And this is the m2 v2. V2 is the change in velocity of that second object. So this is final momentum of B. Yeah. So initial momentum, this is a total. Yeah. So total initial momentum is equal to total final momentum. This is the consideration of linear momentum. So Also, we can write here less, that is linear. Okay. So total final linear momentum. Linear means straight direction. So object after the collision always goes in a straight line direction. So that's why we are saying that linear. Linear means nothing but which is that straight line direction. So before collision also that object moves in a straight line direction. After the collision also that object will go into that straight line direction. So here you can check that is okay. Total initial linear momentum which is equal to total final linear momentum. Okay. So total momentum initial means before collision. Total momentum final means after collision. So total momentum before collision which is equal to total momentum after collision. Okay. So in our rocket motion, so motion of rocket satisfy that law of conservation of momentum. This is a concept of law of conservation of linear momentum. Okay. Now we will go to the one simulation regarding this concept. In this case, you can check that also. Okay. Wait, I will share you. You can check that. Right. Okay. So this is a one simulation for this law of conservation of momentum. You can check that also. Okay. So by theory, you can prove that M1, U1, M2, V2. Okay. But in our practical terms, you can imagine like by using that simulation. Okay. So here, one, this is a first object. Two, this is a second object. And down here, you can see that mass 1 has mass 1 point. You can change that 2 or 3 or something. Okay. So I can put 1.50. So 1.50. So which is the mass of this first object. So second object mass 0.50 kg. This is also will change, but I can take 0.50. Okay. Position means in the Texas, you don't see that position and come into that velocity. You can change the velocity also. Already I told you that first object, A object, will move in a little bit faster than that second object. So that's why collision will happen. So that's why I am changing that velocity, that is 1 for the first object. For the second object, it should be in a slower manner. So 0.50 meter per second. So first object mass 1.50. Yeah, you can check sideways side board. Mass first object. So first object mass 1.50 kg. Velocity 1 meter per second. Please multiply m dot v. So 1.50 into 1, which is gives 1.50 or 1.5. Yeah. So momentum of this first object 1.5 and unit kilogram meter per second. Yeah. So that's why you can see in that here, like you can see. Yeah. 1.50. Okay. So next for the object for that 2, velocity and mass m for that object 2, mass 0.50 kg, velocity 0.50 meter per second. You can change that any value for this in this simulation. You have option like 0 to 3 only. Okay, so you can change the velocity in terms of maximum 3 meter per second, and mass also maximum 3 kg also. Okay, so m 0.50, velocity 0.50. You can multiply. Now you got 0.25. Yeah, 0.25. So this is kilogram per meter per second. So that's why here also you can say, okay, 0.25. Now, this is a momentum before collision. This is a momentum of first object. This is a momentum of second object. You can add those value. You can add those value. That is 1.5 plus 0.25. You will get 1.75. Yeah. So you can add 1.75 kilogram per meter per second. So this is the initial momentum before the collision. Total linear momentum before collision. This is the initial linear momentum before collision. Okay. Now you clear 1.75 kg. So, for example, now you can change. You can see that motion. So momentum 1.50, second object 0.25, first object velocity 1, second object velocity 0.50. Okay. Now you can see that object will come and collide. Okay, collision happens. After that, you can change you can see that momentum changes. Yeah. Okay. So phases. So here you can see that momentum changes. So note it down. For example, after collision, velocity of the first object changes into 0.75. You can see that for the first object, momentum changes because mass does not change, but velocity changes. Before collision, it has 1.00 meter per second. Now 0.75 only. Okay, right. So 1.50, 0.75. You can multiply 1.50 into 0.75. That is 1 P is equal to 1.125. This is a final momentum of that first object. Okay. So this is second object. The second object mass also same. But the velocity changes. Velocity increases 1.25. You can multiply 0.5 into 1.25, which gives 0.625. This is a final momentum of that second object. Yeah. This is a final momentum of the second object. You can see that. Okay. Ball goes like here. Like that. Okay. Okay. So now, so this is a initial momentum 1.5 kg meter per second of that first object. This is a 0.25 of the initial momentum of the second object. Total linear momentum before the collision 1.75. Now mass same, velocity changes. So momentum. This is the final momentum of the first object. So I can put P1. This is the final momentum of the second object P2, 0.50, 1.25, okay? 0.625 multiple. You can multiply this. So final momentum, you can add these two terms, that is 1.125 plus 0.625. So 1.125 and add the 0.625. Now you will get 1.75. This is the final momentum, final total linear final momentum, or else after collision. Okay, total linear momentum after collision. So this is after collision, this is before collision. So you can see that both values same. That is, momentum does not change. Momentum conserved. Momentum conserved means before collision momentum will equal to after collision momentum. Yeah, you can check that by the experiment. Yeah, 1.7, 1 point. Yeah, sir. Mass does not change. Velocity changes. But velocity changes creates a change in momentum. But in terms of total linear momentum, both value before collision, after collision, same. So this is the law of conservation of total linear momentum. Okay. So thank you. Today this topic over. We will discuss another topic in next class. Okay. So this is for today concept on that momentum, impulse, and law of conservation of momentum. I hope you now you have clear understanding of momentum, impulse, and the law of conservation of linear momentum. Okay, right. So if you have any questions, feel free to ask. Okay, any questions do you have? Suppose if you have any doubt, you can chat me, and you can ask me on the next class also. Okay, no question. Okay, thank you. Jai Bharat, Jai Hind, Jai Vidyasat. Thank you.